We've been looking at different methods of solving quadratics. Today we're going to solve some word problems with those methods. So for each of these equations, you're going to set up a quadratic equation that can be solved to find the answer. Then use one of the methods we have studied, so graphing, square root, factoring, or quadratic formula to solve the problem. Afterwards, just make sure that you answer the question that's asked. For this first question, they asked for x. But they could have asked for the length, and then you would have had to plug x into the expression 2x plus 1 to find that length. Our area that they give us is 105, and recall the area of a rectangle is length times width, or base times height. I'm going to use length times width. And they give us the length and the width, so 2x plus 1 times x is equal to my area, which is 105. Go ahead and distribute. So I'll have 2x times x, that's 2x squared, and then 1 times x, which is 1x, that's equal to 105. Subtract 105 from both sides and set your quadratic equal to 0. I don't have a graph, so graphing is not what I'll choose. Square roots is a bad choice because I have a middle term, I have an x term here. Let's look at factoring. Is there anything that multiplies? And we have a leading coefficient of 2, so you have to multiply that with the constant. So it multiplies to negative 210 and adds to 1. And numbers that do that are 15 and negative 14. You will have to split the middle since the leading coefficient is not 1. So I'll write 2x squared, and instead of writing 1x, I'm going to write 15x minus 14x. 15x minus 14x would give you 1x. Then minus 105. Group the first two and last two together. The first group has an x in common. The second group has a negative 7. Make sure you factor out the negative. And then you're left with 2x plus 15. Each of these have a 2x plus 15. So that'll leave you an x from the first group and a minus 7 from the second. Solving this, you can set 2x plus 15 equal to 0, or just do the opposite of your constant divided by your coefficient. So x equals negative 15 over 2. And for this one, x would be 7, would make that 0. Now, you cannot have a length or width equal to 0 in this. That wouldn't make sense. So x cannot be negative. I'll have to throw that one out. You could solve this with the quadratic formula. Since you have to split the middle, the quadratic formula really isn't any more in length than the split the middle on the factoring. If you would solve this with the quadratic formula, I'll go ahead and write an or here. A is 2, B is 1, C is negative 105. You don't have to do this both ways, just pick one. And so quadratic formula, you'll have x equals the opposite of b, so negative 1, plus or minus the square root. B squared is 1 squared, which is 1, minus 4 times a times c, all divided by 2 times a. So that's going to be negative 1 plus or minus. Simplify what's under the square root. Remember, that's called the discriminant. And you'll get 841. That's all over 4. The square root of 841 is 29. And so you'll get two solutions. Negative 1 plus 29, that's 28 over 4. That gives you 7. The other one, you'll do your numerator, negative 1 minus 29, that's negative 30 for your numerator, over 4. And that would reduce to negative 15 over 2, which is the answer I had to throw out. So you'll still get 7 for the answer on this. On example 2, Brian's living room is 2 feet longer than it's wide. So the width is x, and the length is 2 more than the width. So that's x plus 2. And again, I have a rectangle. So you'll do length times your width. So x plus 2 times x. And that is equal to 168 square feet. Distribute x times x is x squared, and then 2 times x is 2x. Subtract 168 from both sides. And then this does factor. It needs to multiply to negative 168 and add to 2. I didn't have a graph, so I wouldn't choose graphing. Square root, you don't want to choose because it has a middle term, so that won't work as a bx term. And quadratic formula would work, but factoring is going to be nice for this, so I think I'll just stick with factoring. On this, the numbers that multiply to negative 168 and add to 2 are negative 14 and 12. The leading coefficient's 1, so you just get to fill those in. So x minus 14, x plus 12, and that is equal to 0. So your solutions, 14 will make that 0, and negative 12 would make that one 0. However, if I plug in negative 12, that means my width is negative. You can't have that happen. So you have to throw that one out. So you get x equals 14. But let's read the question again. What are the dimensions of the room? Okay, so they didn't ask for just x. They asked for the dimensions. So our dimensions are going to be the length, which is 14 plus 2, so 16, and that was in feet, by the width, which is 14 feet. So that is the answer to the question that they asked. For example 3. You are given a quadratic here, and this gives the height h in feet of the largest ocean waves when the wind speed is s knots. How fast is the wind blowing if the largest waves are 15 feet high? So they've given us h here. So I'm going to plug that in my equation for h. So 15 equals 0.019 s squared. And then to solve for this, I need to get my s squared term by itself. You could move the 15 over to the other side. It's not going to factor. The quadratic formula would work, but square roots is a nice one for this one because I don't have a linear term. I don't have any s term, so bx term is not there. So I'm going to divide both sides then by 0.019. And then I end up with s squared equal to, and I'm going to go ahead and carry this out for a ways. I would not round until the very end. So you get 789.4736842 on your calculator. And then to undo a square, you're going to take the square root of both sides. When you do that, you'll get a plus or minus on this side. And then, so you're going to take the square root of that long thing up there. And so s is approximately, let's go ahead and just round this to the nearest tenth. So 28.1. And s is in knots, so we'll include our units on that. And one of those solutions will not make sense. I'll have to throw out the negative one. So s is approximately 28.1 knots. On example 4, the length in feet of a runway needed for a small airplane to land is given by the formula L equals 0.1 s squared minus 3s plus 22, where s is the airplane's speed in feet per second. If a pilot is landing a small airplane on a runway 2,000 feet long, okay, so they just gave us L here. What is the maximum speed? So we're looking for s, which the pilot can land. So I'm going to plug in 2,000 for L. And that's equal to 1/10 s squared minus 3s plus 22. Let's get the 2,000 on the other side. So 22 minus 2,000 is 1,978. And for this one, we don't have a graph. Square roots, we have a middle term, so that's not going to work. Factoring, we have decimal, so factoring, let's not even bother with that one. Quadratic formula is going to be our choice for this one. Let's go ahead and write our A, B, and C down. And so for this problem, we have S equals negative B, so the opposite of negative 3 is 3, plus or minus the square root. When I square B, I get 9 minus 4 times A times C, and that is all over 2 times A. So that'll be 3 plus or minus the square root. The discriminant, which is what's under the radical, is 800.2. And then that's all divided by 0.2. So on my first one, that's not a perfect square, so let's just go ahead and write it like this. You're going to put in parentheses 3 plus the square root of 800.2. And then you'll divide that whole thing by 0.2. And that's going to be 156.44 on your calculator. And on the second one, you're going to have 3 minus the square root of 800.2. Make sure that's in parentheses, and that is divided by 0.2. And that gives you negative 126.44. And I did approximate these, so approximate, they weren't exactly equal. And for this one, it doesn't make sense to have the negative answer. So here is going to be your answer. And let's go ahead and look up our units on that, which were feet per second. It lived in the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function where t is the time in seconds and h is the height in feet. So instead of using x and y, we're using t for x, and for the height, we're using y. This question asks for how long did it take to reach the maximum height. So it wants the time on the maximum height. When you're working with maximums, remember that's the vertex. And I want how long, so that is the x coordinate. The formula is x equals negative b over 2a. In this case, that x is going to be our time, though. So our time, we'll do negative b, so it's going to be negative 16 over 2 times a. And if you look up here, negative 16 was a, positive 16 was b, and 480 was c. That's going to be negative 16 over negative 32, which is 1/2. or 0.5. And that is in seconds. Our next question asks, what was the highest point that Jason reached? Okay, so we're looking for our highest again. So that's the vertex. This time they're asking for the y-coordinate. So I'm going to plug in 0.5, that's the x-coordinate of the vertex, and find the y-coordinate. So my y value, or my height in this case, is negative 16 times 0.5 squared plus 16 times 0.5 plus 480. Enter that in the calculator and you should get 484 feet. And the last thing it asks for is Jason hit the water after how many seconds? Okay, when he hits the water, that's when the height is 0. So you're at ground level. In this case, water level. And so we're looking for the x-intercept. So I'm going to plug in 0. Equals negative 16 t squared plus 16t plus 480. And this does factor. I can take out a negative 16 from everything, and I'll be left with t squared minus 1t minus 30. You could divide both sides by negative 16 and get rid of that. That negative 16 doesn't do anything for the x-intercepts. There's no letter on the outside, so that won't affect it. And then this will factor into, needs to multiply negative 30, add to negative 1, so that's going to be negative 6 and positive 5. And so our solutions would be 6 and negative 5, and of course the negative 1 does not make sense. So this is t equals 6 seconds. And we have completed this first day of word problems.